Let's look at the first unit of the FCM3 syllabus, or the course outline rather. Upon successful completion of this unit, what you will be able to do, draw and interpret graphs of quadratic functions to determine, for example, the elements of the domain that have a given image of a given element in the domain, maximum or minimum value of the function, okay, the equation of the axis of symmetry, and those things are going to. Let's look at an example of a graph. First of all, I'm going to open GeoGebra and look at an example of a graph. Now, it talks about quadratic function. We're going to look also at the linear function and see the difference between it and the quadratic function. Suppose I have a graph and it says I must plot y equals x. Y equal x. That's the line y equal x. It is y equal x because when y is 2, x is 2 right here. When y is 4, x is 4. You can see that. When y is 6, x is also 6. This is a linear function. Alright? It gives a straight line. It means the power of x is 1, because I could say to the power of 1. And it's the same thing. Now a quadratic graph is one with the power of x 2. If I say x to the power of 2, then you see that as a quadratic graph. This graph, you could plot it by saying when x is 1, y is 1 squared, which is 1. When x is 2, y is 2 squared, which is 4. When x is negative 1, y is 1 squared, which is also negative 1. When x is negative 2, y is 2 squared. When x is negative 1, y is negative 1 squared, which is positive 1. Negative 1 times negative 1 give you a positive 1. When x is negative 2, y is negative 2 squared, and negative 2 squared is positive 4. So you could plot this graph if you wanted to. Alright? Now, what are the values of x when y is between 0 and 1? What you could look at here is that x is 1, y is 1, that's one value. X is negative 1, y is also negative 1, that's another value. I'm going to take a screenshot of this and then open it in another software and see what it's all about. Let me call this picture FCM3U1 so that I can find it, or FCM3 space 1. Now I want to look at the software, open Sun Core, and open it from there. So in this case, what you have is a quadratic function, and you have a curve, and this curve is in the form of a parabola. want to find back the file that I had saved earlier. Now, let me go back here and paste that. Now let's look at this. You can see that when x is 2, y is 4. And that's because when you multiply 2 by 2, you get 4. Because this is 2 squared, that gives you 2 by 2. Over here, you have negative 2, put it in brackets, time negative 2, give you a positive 4, because you have negative time negative, give you the positive. Now, let me change the function a bit, the function that I had earlier. I have this graph, and I want x squared plus 2. X squared plus 2. When I click OK, you notice what it did? It lifted the curve 2 places. What happened is that each term that was the answer for x squared, 2 was added to it. So it lifted the graph 2 places upwards. Alright? Lifted it 2 places upward. I want this graph to be a little thicker than it is now. Alright. Now, suppose I say x squared minus 2. What would happen? Here, it pulled the graph down 2 places. Because remember, you know, what we had originally was x squared. 0 squared is 0, so this point is called the minimum point, the lowest point on the graph, and it is at 0. When I said minus 2, x squared minus 2, it pulled everything downwards, because each point that you get for x squared, when you say minus 2, 0 minus 2 is negative 2. When the point was 1, 1 minus 2 is negative 1. So here came down here. Right? You had 2 squares 4. But 4 minus 2? 4 minus 2 is 2. So right at the point above 2, it was beside 4. Now it dropped down to 2. So you can see that, right? Alright, so here now, what I want to do is make a little modification. Let me put it back to x squared. This is the graph of x squared. Suppose I say instead of x squared minus 2, what I do is open bracket and say x minus 2 close bracket all squared. What would happen? Let's see. You see what that happened? When I go into the square and I say x squared minus 2, it moves 2 places to the right. Suppose I say minus 3, it moved 3 places to the right, from 0 to 3, because if I go back to x squared alone, the minimum point is right here in the middle. And when I go into the square and say x minus 3 all squared, when I say x minus 3 all squared, it moves 3 places to the right. Alright? Now let's make a little change. Let's go back to x squared. It goes back to the center. Then what I'm going to do is try x plus 3 this time. Plus 3 close bracket r squared. What do you think would happen? A while ago I said x minus 3 r squared and the graph moved to the right. When I say x plus 3 r squared, you expect it to move to the left. 3 places to the left. You see that? So let's look again. Here I put x squared, and all that happens is that you have the graph right at the center. When I say, for example, x squared plus 3, it moves up 3 places. Let's put it back. X squared alone, back to 0. When I say x squared minus 3, it moves it down 3 places. When I'd put the 3 within the square. Positive 3, it moves to the left. Negative 3, it moves to the right. So in this case, x squared plus 3, close bracket, the graph would have moved to the left. And when I change the plus to minus, it moves to the right. Alright? Now, let's do a little thing. Let's go back to x squared. And I'm going to have the graph right in the center. Alright? This is x squared. I'm going to do both things. I'm going to say x plus 3, close bracket, I'm going to say x plus 3, close bracket. Then outside the bracket I have plus 3. Now, a while ago, within the bracket the plus 3, move it to the left. And outside the bracket the plus 3, move it up 3 places. So let's see what happens in this case. You notice what happened? The plus 3 within the bracket, move it to the left. Move the center, the lowest point, the center of the curve, the lowest point of it, it moves to the left 3 places. And the one outside the bracket, the 3 outside the bracket, the plus 3, move it upwards. So you see, this plus 3 inside the bracket move the point 3 places to the left, and the plus 3 outside the bracket move the point 3 places up. Good. Now, if you should multiply out x plus 3 squared, let's go back to x plus 3 r squared. This is the graph of x plus 3 r squared. Remember, x plus 3 r squared. Let's multiply out x plus 3 r squared and see what happens. What I have is plus 3. So I have x plus 3 all squared is equal to x plus 3 times x plus 3, which is x squared plus 3x plus 3x plus 3 squared. That x plus 3 are squared. So you have x squared plus 3x plus 3x is 6x plus 3 is 9. X squared plus 6x plus 9. X squared plus 6x plus 9. Let's change this a bit. X squared plus 6x plus 9. X to the power of 2 plus 6x plus 9. What would happen? It stays put. This is the same function as x squared plus 6x plus 9. So you see here x squared plus 6x plus 9, that's x squared plus 6x plus 9 can be written as x plus 3 all squared. Alright, now what this tells you, what this inside the bracket tells you, is that the curve x squared will move horizontally 3 places to the left. Alright, now this form will give you a clue as to where the center of the graph is located. If you look at this graph, this line here that passes through -3 is called the axis of symmetry, and generally the equation of the axis of symmetry is written as x equal -b over 2a. When you have the function in the form a x squared plus bx plus c, here you have x squared and ax squared. Remember, when you have x squared, it's really 1x squared, so a is in the place of 1 in this function. B multiplies x and 6 multiplies x, so in this case b would be 6 plus c, and this says plus 9, so c would be 9. We'll continue a little later and look at this topic some more.